Another most important point before proceeding further is you have to remember this particular important point. The order of global stiffness matrix capital letter K. In turn, the order of individual element stiffness matrices K1 and K2 is directly proportional to total count of the nodes into 1. In this particular sentence, 1 indicates one type of displacement occurring at each nodes of the given shaft structural member. From the FER, your mind must have clarity over this information. That is, due to application of torque, only one type of displacement known as angular displacement is occurring, which means one node, one displacement, two node, one displacement each at nodes, three nodes, one displacement at each of the nodes. Thus, the total or the final order of global stiffness matrix, in turn the individual element stiffness matrices, depends upon the total count of the nodes into 1. That is, in this particular problem there are 3 nodes, 3 into 1 displacement at each of the nodes. Thus 3 into 1 is equal to 3. So 3 cross 3 is the order of K1, K2 and capital letter K. Implementing this rule within the matrix, as you can see at the top end of this particular sheet, we have written dummy zeros along third row and third column for K1 matrix as well as along first row and first column for K2 matrix. This signifies that in element E1, nodes 1 and 2 are present, node 3 is absent. Node 3 is absent. This means you include zeros along third row and third column. Similarly, using the same logic, since in element E2, nodes 2 and 3 are present and node 1 is absent, this means you include dummy zeros along first row and first column of the K2 matrix. Write the numbers which are already obtained for K1 and K2 in the remaining locations of the matrix. After adding the two matrices, you are going to get the final answer for capital letter K, which is equal to 10 to the power of 4, common number taken outside the matrix, into multiply each of the numbers at each of the location relevantly and correctly, then you are going to get an answer what has been shown in the middle portion of this particular sheet. Now, using the governing equation of FEA, we are going to write the equation, that is K into theta is equal to T. Substitute the value of governing equation of FEA with the parameters K, theta and T. That is, substitute the value of global stiffness matrix numbering in K position. Substitute the value of theta matrix as theta 1, theta 2, theta 3 given within the FER, and the value of T as T1, T2, T3, which is also given in FER presentation.